Welcome back, my dear students. We were with the numericals of chapter heat and we had solved a few numericals in the previous class. I hope you went through those sums. What thing that you have to remember before we get into the other two numericals? Always remember, when the state of a substance changes from solid to liquid or from liquid to gas, when the state of a substance changes, you will use the formula ml. Okay? Latent heat and mass multiplication. When the temperature of a substance changes, temperature changes. When will the temperature change? When heat is absorbed or heat is given out. At that time, you will use the formula mc delta T. Now, suppose the state of a substance is changing and the temperature is also changing. So, you will add both these formulas. Okay. So, these all things we had discussed in the previous two sums. Same way we will solve these two sums. The sums are very easy. Only these two formulas you have to apply. Okay. So don't think that the numericals are pretty tough. I am there to explain each and every detail. You just have to understand, think from your side and apply it. Okay. Now here you can write the steps according to your format. There is no hard and fast rule that what is given in the digest or what is given in the textbook that you have to follow. Main formulas, we will see whether you have used these formulas. Writing the formula is important, whereas the introduction or using the suffixes, W for water you can use or 1 or 2 you can use as the suffix, that all doesn't matter. Okay. So with that note, let us take the next sum. Okay. A thermally insulated pot has 150 gram of ice at temperature 0 degree Celsius. Read it again and frame the scene in your mind. A thermally insulated pot. Okay. So you have a thermally insulated pot. Thermally insulated pot means heat will not go out, whereas the heat will not be absorbed. The outside heat can't enter this pot. It is thermally insulated. No heat exchange is possible. Okay. Whatever is there inside, in between that, there is heat exchange. No heat will go out or no external heat can enter this pot. Understood? So you have a thermally insulated pot and it has 150 gram of ice. In this pot you have ice. Okay? In this pot you have ice and the temperature of ice is 0 degree Celsius. Okay? In the pot you have ice and the temperature of ice is 0 degree Celsius. This much is okay. Now, next to see. How much steam of 100 degrees Celsius, steam, okay, steam, when water boils, you can see the vapor going up. In this corona season, we all take steam. Okay, so steam is not a new word for us. Yes. So now, how much steam of 100 degrees Celsius has to be mixed to it so that the water of temperature 50 degrees Celsius will be obtained? I did not understand anything. Read the second part once again. One thing we understood, there is a thermally insulated pot. Uske andar hai ice. In that you have ice of 0 degree Celsius. Now to that you are supplying, to this you are supplying steam. And what is the temperature of that steam? The temperature of the steam is 100 degrees Celsius. Obviously when water boils, okay, it will be in liquid form and then vapor form, 100 degree Celsius. Steam in 100 degrees Celsius has to be mixed to it so that, so this steam we are putting inside the inside this pot so that water of temperature 50 degrees Celsius will be obtained. Now obviously when you pass steam, heat, steam means it is heat of 100 degrees Celsius, if you pass into this ice, the ice will start melting. Common sense, no? Ice will start melting. When you pass the steam into this ice, the ice will start melting. And what will be the next process? This ice which is at 0 degrees Celsius will get converted into ice water. Ice will melt, okay, and it will get converted into another state. From solid state, it got converted into liquid state. So which formula you will use? ml. When the state changes, ml. Okay, this ice water will be of 0 degree Celsius only, okay. Ice started melting when you put steam into that. So 0 degree Celsius का ice अभी melt होके it became water of 0 degree Celsius, cold water. Now again, because of the steam, this ice water will absorb heat. Everywhere absorption of heat is going on. So again it will absorb heat, and we want the water to reach how much temperature? See the question. We want the temperature of the water to be at 50 degrees Celsius. So how much steam you should put into this ice so that that ice will melt and that water will be converted into 50 degrees Celsius water. Understood? Okay. So our question is how much steam? Our question is how much steam should be given? That is mass of the steam is asked. How much steam should be given to this ice so that what all action should take place here? Ice should melt. Okay. Temperature is same. So you will use the formula ml. State is changing means ml. अभी यहाँ पे क्या हुआ? From 0 it has to go to 50. I am not saying, they are saying in the question. We want the water to be at 50 degrees Celsius. 0 say 50 degrees Celsius. So here the temperature is changing. Heat is absorbed. When heat is absorbed, the temperature increases, no? Okay. So here you will use the formula mc delta T. Understood what is happening to ice? So the question is, how much steam should be given? What is the mass of the steam? Understanding? What is the mass of the steam? Now what do you think? The steam will be just like that, just it will melt the ice and it will go? No, steam also has a story to say. What is the story of steam? Now let me show you about steam. So we have steam of 100 degrees Celsius. We put it in ice. What will happen? With the help of the steam, 100 degrees Celsius steam, the ice will melt. Okay. Now when the ice melts, the steam is giving its heat, no? It is giving heat. So will the temperature of the steam increase or decrease? Common sense. Steam is with ice. Ice is cold. Steam will give heat to ice. So the temperature of steam will increase or decrease. Steam is giving heat to ice. Temperature of steam will increase or decrease. Yes, I got the answer. Decrease, no? So the temperature of steam will decrease. Now, when this steam comes in contact with the water, it will form condensation droplets. Steam, if you put a lid onto the steam, if you hold a lid onto the steam, when the water boils, as you see the steam coming up, when you hold a lid onto that, you can see water of condensation. So the steam which is in vapor state will be converted into liquid state. Yes or no? That will also happen here. So that is not given in the question. That is your knowledge. That's why we learnt about condensation. What will happen? When the vapor comes in contact with the ice, some vapor will undergo condensation. That means the steam which is in gaseous state will be converted to water which is in liquid state. So when the state changes, which formula will you use? When the state changes, which formula you will use? You will use the formula ml. Understood? Okay? ml. So here you will use the formula ml. So here you have liquid. Now again, it is giving heat and it is giving heat lost. So you have to use the formula mc delta T. Okay, so the steam and this water finally will attain 50 degrees Celsius. Story of ice is clear. Okay, what is happening with steam? 100 degrees steam, when it goes and interacts with the ice, first the steam will undergo condensation. Okay, that means the state changes. State change hua to we will use the formula ml. Okay, then it will keep on giving its heat to the ice so that the ice will get converted into water. And when all three attain the same temperature, thermal equilibrium, Till when the heat exchange will take place? Till all attain the same temperature. That is, this calorimeter, that is a pot, insulated pot, ice water, this water and the steam, all will attain 50 degrees Celsius. That is a question. We want the water to be at 50 degrees Celsius. It is given in the question. So we want to find out how much is steam. This is what you have to find out. Mass of the steam. I hope you understood. Okay. So with this knowledge, I explained you the sum. Let us solve it. Now I have written about ice. All the details about ice, let us write. Mass of the ice, I have taken Mi. For ice, I am using I. If you want, you can use 1 or 2. 1 for ice and 2 for the steam. Okay, I am using I. What is the mass of the ice? Thermally insulated pot has 150 grams. So this is 150 gram of ice. Temperature of the ice. What was the temperature of the ice? Initial temperature 0 degree Celsius. Okay. Latent heat of fusion. Ice is going to melt. This is the story that you have to tell yourself. Ice will melt. So it is latent heat of fusion of ice. It is given in the question. Latent heat of melting of ice is 80 calorie per gram. Okay. That is given. 80 calorie per gram. Understood about ice? Huh. Now what is happening to this ice? Therefore, steam will give heat. Ice is going to absorb heat. Understood, no children? Ice is going to absorb heat. So we will write heat absorbed by ice is equal to, write down, two process is going to take place here, which is MC delta T plus ML. What is going to happen here? It is going to absorb heat as well as the state is also going to change. We discussed this. Ice will get converted into ice water first and then it is going to absorb heat and reach 50 degrees Celsius. Okay. So let us write M, mass of the ice. Here you write I, here you write I, and here also you write I. I for ice. Mass of ice and latent heat of fusion of ice. Okay. Everywhere I added I. Now Mi, mass is 150 into, how much is Ci? Ci, that is specific heat of ice or water is 1 only. So write 1 and delta T. Now delta T, what is the change in temperature that we want? Ice is at 0 degrees Celsius. We want the ice to melt and reach 50 degrees Celsius. Okay. So bigger number minus smaller number. Initially it is 0. We want it to reach 50 degrees Celsius. So you will write 50 minus 0 in place of delta T. Understanding? Plus, okay, mass of ice again 150 into latent heat of fusion of ice is 80. Okay, this you keep as it is. This is all regarding ice. Now let us solve the same thing about steam. Mass of steam we don't know. So that is Ms. Steam S. Mass of steam we don't know. That is a question. Temperature of steam. The initial temperature of steam was 100 degrees Celsius. That steam is also going to condense and it will get mixed with water and it is also going to reach the temperature of 50 degrees Celsius. Latent heat of vaporization will come here. Okay. So latent heat of vaporization is given. Yes, latent heat of vaporization of water is given as 540 calorie per gram. Understood? Steam ho, ice ho, both are water. Specific heat is 1 only. Okay, you can specify that here. Specific, in the previous part I didn't write. Try to write it there also. Specific heat of ice as well as of steam is going to be one and the same. Ice, water, steam all will have the specific heat capacity as 1 calorie per gram degree Celsius. Okay. This I did not write in the previous part. You mention it. Just write specific heat of ice in the previous part. Okay. Now what is going to happen here? The steam is going to lose heat. Okay. So the heat lost by steam is equal to, again, MC delta T. Steam state is also going to change. Steam is in gaseous state. when it will undergo condensation, it will get converted into liquid state. So whenever state changes, you will introduce ml. Now for steam, we will write ms, specific heat S, delta Ts and ms, and latent heat of vaporization as ls. Substitute the values here. Mass of the steam we don't know, so that will be ms. Cs 1, specific heat of water is 1 into here delta T. Initially when the steam came, it was at 100 degrees Celsius. When it will get converted into water, the temperature will become 50 degrees Celsius. So what is the change? 100 minus 50 plus mass of the steam we don't know. Latent heat of vaporization is 540 calorie per gram. No need to write the units anywhere here. Now this will remain. Let us solve the bracket. ms bracket 50 plus 540 ms. Ms write as small, otherwise you will be confused what is this S. This is mass of the steam. Now what initially we got? Heat absorbed by ice. Now we got heat lost by steam. And what did we learn? We learnt about principle of heat exchange. Every hot object will give heat to a cold object, and the quantity will remain equal. Heat lost by a hot object is equal to heat gained by the cold object. So same way here, heat absorbed by the ice is equal to heat lost by the steam. So by the principle of heat exchange, very important step, so you have to write. By the principle of heat exchange, heat absorbed by ice is going to absorb heat, is equal to heat lost by steam. So I have written all the details. For ice we have written I. So mc delta T plus ml is equal to mc delta T plus ml. Only you have to change the suffix. Here for ice, all I, and here steam, all S. And what is delta T? Delta T is 50. Just substitute the values here. 150 was the mass of water. Water specific heat is 1. Delta T we had got 50 from the previous part, plus mass will remain same 150, and latent heat of fusion of ice was 80 is equal to mass of steam we don't know, so ms will remain as it is. Steam's specific heat is 1, delta T is 50, 100 minus 50, 50, plus mass of the steam we don't know, and latent heat of vaporization of water is 540. 540. Now let us solve this equation. So let's solve 150. This one we will solve. 150 into 50. 5 5s are 25, carry 2, 5 5 is 75, 0 0. Plus multiply, 8 zeros are 0, 8 5s are 40, carry 4, 8 1s are 8, 12 and 0. You do, and I will also do the calculation. We will check. 50 ms means mass of steam, plus 540 ms. So this both you can add. 540 plus 50 will become 590. So what will be the next step? I'll rub this part. So from here, 7,500 plus 12,000 will give me, correct no? Is equal to 590 ms. Ms means what? Mass of the steam. 590 ms, mass of the steam. Add this 0 0 5 9 and 19,500 is equal to 590 into ms. So we will keep ms there. Therefore 19500 divided by 590 is equal to mass of the steam. Do the calculation. 0 0 cancel. Let me divide. 1950 divided by 59. 59. So I want 3s I'll take. 9 3s are 27, carry 2, 15, 17. Very close. So I'll go for 3 is a 177. 15 minus 7 is 8. 8 minus 7 is 1. Just 0 down. Now 180. Very close. Again we'll take 3. 3 is a 177. Subtract. I'm doing the calculation also for you. 10 minus 7, 3. 7 minus 7, 0. Put a decimal point. Put 0. Again a decimal point because 30 is smaller number. Okay. Again a 0. So we can add on 0 here. Now 59 into 6 will not happen. Let us try 5 9 5 45, carry 4. 5 5 25, 29, 295. Okay. After decimal point, 2 digits is enough. So we got 33.05. For MS, mass of the steam, how much we got? 33.05. 33.05 grams. 33.05 grams. 0.05 grams of steam is required. That's it. Easy. Now let's go on to the last sum. I'll read the question. A calorimeter has mass 100 grams and specific heat 0.1 kilocalorie per kilogram degree Celsius. Okay. A calorimeter, this is about calorimeter. Same story. Insulated pot and calorimeter. Calorimeter is something like this. Cylindrical vessel which is again insulated. No heat exchange will happen from the calorimeter outside as well as from outside into the calorimeter. Insulated pot. Okay. So this is all insulated pot. In this calorimeter we have water. We have water. Okay. In the calorimeter we have water. Mass of the calorimeter is given. Specific heat. Calorimeter is made up of a substance and that substance specific heat is given. It contains 250 gram of liquid at 30 degree Celsius. Let us consider the liquid to be water. Okay. So in this calorimeter we have 250 gram of liquid at 30 degrees Celsius. Okay. So not that hot water and all. 30 degrees Celsius liquid is there in that dabba. Calorimeter. Having specific heat of 0.4 kilocalorie per kilogram. Specific heat of this liquid also we know. 0.4 kilocalorie per kilogram. So all three details about liquid we know. If we drop a piece of ice. So till now the story is very easy. Calorimeter is there. In that you have water. Whatever will be the temperature of the water, same will be the temperature of the calorimeter. So now at present, what is the temperature of calorimeter? Temperature of water is 30. So calorimeter का भी temperature होगा 30. Till villain comes. Who is that villain? Ice. Okay. Who is coming into that? Ice is taking an entry into that. What about ice we know? If you drop a piece of ice of mass 10 gram, ice mass is given, temperature 0 degrees Celsius. What will be the temperature of the mixture? So as soon as ice enters the liquid, all story changes. Okay, what will happen? I'll give you few minutes to think what is going to happen. Thought? Now at present we have liquid which is at 30 degrees Celsius. To that, who is coming? To that ice which is at 0 degrees Celsius will enter. Now there something is going to happen between the liquid and the ice. Okay, heat exchange, heat lost, heat exchange is going to happen. Somebody is going to absorb heat, somebody is going to lose heat. Who is going to absorb heat and who is going to lose heat? I hope you got the answer. Ice is going to absorb heat. Okay. Whereas this liquid is going to lose heat. Correct? Ice will enter the liquid. What will happen to this 30 degrees Celsius water? Will it boil? Will it start boiling? Obviously no. Ice is entering, no? So it will make the water cooler. So from 30 degrees Celsius, the temperature is going to decrease of liquid. Ice के साथ क्या होने वाला है? From 0 degrees Celsius, the temperature is going to increase. Am I right? Okay. Liquid is at 30 degrees Celsius. As soon as ice comes, what will happen to the liquid? The liquid will become colder because of the ice. Colder means the liquid is going to lose heat. Ice is going to gain heat. Okay. When will this continue? Till thermal equilibrium, or by the principle of heat exchange. Heat lost by the hot object is equal to heat gained by the cold object. Understood? Okay. So one by one we have to write the details. Okay. So I have written the details about calorimeter and liquid. Okay. I'll highlight that. Mass of the calorimeter. From the question, right? Mass of the calorimeter is 100 grams. Now delta Tc of calorimeter. Initial temperature was 30. Okay. When ice comes, obviously the temperature is going to decrease. So bigger number 30 minus T. We don't know that temperature. That temperature is a question. So 30 minus T. Specific heat of calorimeter is given as 0.1 kilocalorie per kilogram. 0.1. Okay. Then next about liquid I have written. Mass of the liquid 250 gram. 250 gram. Delta TL of the liquid. Liquid was at 30 degrees Celsius. When ice comes, the liquid will also lose its temperature. The temperature will decrease, no? Okay, it will get colder. The liquid is going to get colder. Colder means temperature decrease. So again this will be 30 minus how much decrease we don't know. T. Understood? Now specific heat of liquid. Specific heat of liquid is given as 0.4 kilocalorie per kilogram. 0.4 kilocalorie per kilogram. Okay. This is all about calorimeter and liquid. Now let us write about the ice. So mass of the ice, we drop a piece of ice of mass 10 gram. Mass of the ice is 10 gram. Specific heat of ice is obviously 1 kilocalorie per kilogram. Okay. Specific heat of water, steam, ice, everything is 1. Delta Ti. Ice is at 0 degrees Celsius. जब भी आया, ice was at 0 degrees Celsius. Liquid के साथ mix होगा तो the temperature is going to increase. From 0 it is going to increase. No? So increased temperature we don't know. Minus, what was the initial temperature? T minus 0. So delta Ti of ice is T minus 0. I hope you are understanding. Now we will apply by principle of heat exchange. Now who and who are going to get involved in this heat exchange? Heat lost by calorimeter plus, who else is going to lose heat? Calorimeter के अंदर क्या था? Liquid. Heat lost by calorimeter plus heat lost by liquid is equal to lost by liquid is equal to heat gained by, who is going to gain heat? From 0, who is going to gain heat? Yes, heat gained by ice. I hope it is clear, children. Okay. Tried by level best. Heat lost by calorimeter and liquid is going to lose heat. Ice is going to gain heat. And both will be equal according to principle of heat exchange. Heat lost by the hot object is equal to heat gained by the cold object ice. Okay. So now let us put the values here. Write down for calorimeter. Write MC delta T plus MC delta T for liquid. And then change the suffix. Okay. So for calorimeter I'll write MC delta T. For calorimeter everywhere put C. C for calorimeter. Plus for liquid again MC delta T. Here state is not changing. For liquid write L is equal to heat gained by ice MC delta T plus ice is getting converted into liquid, so ml. Latent heat of fusion. Ice is getting converted into liquid, so latent heat of fusion will be introduced here. Now put the values from the given part. Put the values. MC delta T plus MC delta T is equal to MC delta T. This is for ice, so I everywhere. I for ice. Fine. Now here mass of the calorimeter 100, specific heat capacity 0.1, delta T is 30 minus T plus mass of the liquid is 250, C specific heat is 0.4 and delta T will be the same 30 minus T is equal to mass of the ice is 10, specific heat of ice water is 1, delta T will be T minus 0 because ice is going to absorb heat. The temperature badega. That temperature we don't know. So T minus 0 plus mass of the ice 10 and this is latent heat of fusion. So it is given in the previous sum. Latent heat of melting of ice is given, no? 80. So same you will write here. Okay. Calorie per gram and kilocalorie per kilogram, the value will remain the same. 80. Fine. To solve this equation, 100 into 0.1 will be 10, 30 minus T. Correct? 250 into 0.4 will be 100. Please check once again. 30 minus T is equal to, check this once again, this multiplication, is equal to 10 into 1, 10. 10. T minus 0 will be T plus 100 into 80 will be 800. Solve the remaining part. 30 minus T common I will take. So take 30 minus T common. What will remain is this 10 plus 100 is equal to, this will be 800 plus 10T. Fine? Now 100 plus 10 will be 30 minus T multiplied by 110 is equal to 800 plus 10T. Fine. And now open the bracket. This will be 110 into 30 minus 110T is equal to 800 plus 10T. This will be 11 3s are 33 and 2 zeros. Minus 800 is equal to, 800 I have brought here, 10T plus 110T. Subtract, therefore 0, 0. 13 minus 8 is 5 and this is 2 is equal to 120T. So therefore 2500 upon 120 is equal to T. 0, 0 cancel. So now I will divide. I am going to divide 250 by 12. 250 by 12. 12 2s are 24. 1 0. So this is not going. So I will put a 0 here and decimal point. Now 12. 12 8s are 96. Correct? 10 minus 6 4. And this will be 0. 12 3s are 36. Okay, after decimal point 2 digits you got. So we are satisfied. So therefore T is equal to 20.83 degree Celsius is the answer. Okay. So just you have to understand the concept. With this we have completed the chapter heat with the numericals. Go through the numericals with a peace of mind, with calm mind. Go through the numericals. Learn it very well. Now in the next class we will start with a new chapter. Till then, bye.